Welcome to EDU World Space.
So in this video, we're going to talk about question 78 from chapter 20, which says, for the RNFX compounds the predicted in exercise 77, give the molecular structure, including bond angles. So in exercise 77, we're told that radon reacts with fluorine to form fluorine compounds in the same way that xenon reacts with fluorine. So we know that xenon forms fluorides that are XeF2, XeF4, and XeF6. So radon must form fluorides that are RnF2, RnF4, and RnF6. So let's start drawing the Lewis structures for these, and then we'll get the molecular structure. So the first one is RnF2. So we know that radon is going to bring 8 valence electrons, and our 2 fluorine atoms will bring 14 valence electrons. That gives us 22 electrons overall. Then we can just draw radons with single bonds to both of the fluorine atoms and fill in the octet on the fluorine atoms. That leaves us 6 electrons left over, so we put 3 lone pairs of electrons on radon. So then we have 2 bonded atoms and 3 electron pairs. That tells us that our molecule is linear. So we have 1 fluorine atom above radon and 1 below radon, and 3 electron pairs around the kind of equator of the molecule. So the geometry is linear and the bond angle is 180 degrees. The next one we have is RnF4. So we know that radon brings 8 valence electrons and each of our fluorines brings 7 valence electrons. That gives us 36 electrons overall. So again, we just draw our central radon atom and then our fluorine atom surrounding that with single bonds, and then we just fill in the octet on our fluorine atoms. And after we do that, we have just 4 electrons left over, so we put 2 lone pairs of electrons on our central radon atom. So the fact that we have 4 bonded atoms and 2 electron pairs tells us that our geometry is going to be square planar. So what does that look like? Well, that looks like 1 electron pair above our radon, 1 electron pair below our radon, and then a square around the equator of our central atom, of our molecule. We have our 4 fluorine atoms. So the bond angle here is 90 degrees. It's square planar geometry. The next one we have is RnF6. So again, radon brings 8 valence electrons and fluorine brings 7 valence electrons. 7 times 6 gives us 42. That's 50 electrons overall. So we just draw each of our 6 fluorine atoms singly bonded to our central radon atom, then fill in the octet on our fluorine atoms. After we do that, we have just 2 electrons left over. So we have 6 bonded atoms plus 1 electron pair, which we're putting on our central radon atom. So 6 bonded atoms plus 1 electron pair tells us that we have a pentagonal pyramidal geometry. So what does that look like? That looks like 1 fluorine atom below our radon atom and an lone electron pair below. And then around the equator, we have a pentagon made up of 5 fluorine atoms. So the bond angle between the fluorine atoms around the equator are 72 degrees. And the bond angle between our fluorine atom that's bonded vertically to our pentagon of fluorine atoms is 90 degrees. So this is a pentagonal pyramidal geometry.